Welcome. Today, we're doing something a little different. We're not just going to answer an exam question, we're going to crack the code behind it. We're going to get right inside an examiner's head by taking apart the official mark scheme to see exactly how and why every single point gets awarded. So let's dive in. So here we have it, a real AQA GCSE Physics paper. We're going to zoom in on one specific problem, question 07. It's a multi-part question that tests a whole bunch of skills, and it's a perfect example of how calculations, theory, and circuit analysis all get woven together. Okay, so here's our game plan. First, we'll unpack the challenge itself, question 07. Then, we'll tackle each part one by one, the calculation, the relationship question, and finally, the faulty circuit. And to wrap it all up, we'll get to the most important bit, learning how to think like the person who's actually marking your paper. All right, let's get into it. Section 1, the challenge. Let's get a really good look at our mission here. This is question 07, and we are going to pull it apart, piece by piece. So here's the entire problem all laid out. You can see on the left, we've got a calculation and a question that needs a conceptual explanation. Then on the right, there's a faulty circuit that we need to figure out. It's a proper workout for our physics brain, testing three totally different skills all in one go.
Right then, on to our first task. We're starting with the numbers. This is part 1, the calculation. Let's get to it.
Okay, so the question tells us the battery had a power output of 230 milliwatts when the resistance of the variable resistor was 36 ohms. And our job is to determine the potential difference across the battery. And look at that, 4 marks are up for grabs. So our mission is to figure out exactly what we need to do to get every single one of them.
So here's the big question, right? What does a perfect 4-mark answer actually look like? Well, you might be surprised to find out that there's more than one way to get to the right answer.
And this is a really key insight into how exams are marked. There isn't always just one single right way to do things. In fact, the official mark scheme for this question lists 3 completely different but equally valid methods. Let's walk through all of them. Okay, method 1 uses the power law. First thing you do is find the current from the graph provided earlier in the paper, which is 0.08 amps. Next, and this is super important, you've got to convert the power from milliwatts into watts. Then you rearrange P equals I times V to solve for V, and finally just plug your numbers in to get 2.875 volts.
Now method 2 is probably a bit more direct. It just uses Ohm's law. Again, you start by pulling the current from the graph, 0.08 amps. The question already gave you the resistance, 36 ohms. So you just substitute those values straight into V equals I times R, and boom, you get 2.88 volts. Simple as that.
Method 3 is a little different. It's more of a two-step approach. Here, instead of reading the current from the graph, you actually calculate it using the power and resistance. Once you've done that and found the current is 0.08 amps, you then just use Ohm's law like we did in method 2 to find the potential difference, and you get the same 2.88 volts. It's a great example of how you can use different physics principles to get to the same place.
And here it is, the source of truth itself. This is the official mark scheme. Everything we just went through is laid out right here. This isn't just someone's opinion or a textbook interpretation. This is the literal rulebook the examiner has to follow. What's written on this page is all that matters. Now, this is absolutely crucial. Check out the extra information section. The mark scheme has lifelines built right in. If you mess up reading the current from the graph, you can still get full marks for all the following steps as long as you use your wrong number correctly. It's called error carried forward. The same thing applies if you make a mistake converting the power. And, get this, a correct final answer with no working out can get full marks. But trust me, showing your work is always the safer bet. Okay, we've crunched the numbers, so let's move on. Part 2 isn't about calculations. This one is all about explaining a fundamental relationship in physics. It's about the why. So, the question gives us a conclusion that a student made. Current is inversely proportional to resistance. Our job is to explain how the graph from the exam paper proves that the student is right. This is really a test of how well you can interpret data.
So, how do you lock in auth marks here? Well, the mark scheme is super specific. For the first mark, you have to state the definition, that for an inversely proportional relationship, the product of the two variables, I times R, is a constant. For the second mark, you have to actually prove it by calculating that constant for at least 3 different pairs of values from the graph. There's even a little safety net. If all else fails, just stating that doubling one quantity halves the other can still get you 1 mark.
Okay, on to the final part of the question. Now we're in a real problem-solving scenario. We've got a circuit that's been wired up wrong, and our task is to predict and explain what happens next. Take a really close look at this circuit diagram. You can see the switch has been put in parallel with the variable resistor, which is a classic error. The question is very specific. Explain how closing that switch would affect the current in the variable resistor.
The mark scheme breaks this down into two very clear parts, a what and a why. First, for 1 mark, what happens? The current in the variable resistor drops to pretty much 0. Simple. Second, for the other mark, why does this happen? Well, because closing that switch creates a new path with almost no resistance. And we all know electricity takes the path of least resistance, so it just bypasses the resistor completely. That's a short circuit, and explaining that gets you the second mark.
Okay, we've dissected the entire question. Now, let's zoom back out and really hammer home the most important lessons. It's time to put on our examiner hat and think about the key takeaways from all this. So let's boil this all down. For calculations, remember that error carried forward is your best friend. One little mistake at the start doesn't have to ruin everything. For relationship questions, be specific. Saying the words is good, but proving it with data is what gets you the top marks. And finally, for any kind of fault or change in a circuit, always explain both what happens and why it happens. They are almost always marked as separate points.
So, we've walked through all the answers, we've seen every method, and we know where every single mark comes from. But the real lesson here isn't just about this one question. It's about seeing the pattern underneath it all. Mark schemes aren't just a list of right or wrong answers. They are a blueprint for rewarding clear, logical thinking. If you can apply this kind of analysis to your own revision, you're not just learning physics, you're learning to speak the language of the exam.